Let's start our new series, MPLS Basic to Advanced with Traffic Engineering. So MPLS stands for the multi-protocol level switching because traffic will be switched based upon labels. If you are familiar with the traditional IP network, where traffic is forwarded based upon the IP, right, or the networks. So in MPLS, traffic will be switched based upon the labels that we will study in detail. So let's see a quick historical point of view related to the multi-protocol level switching. So if we talk about old days, let's say we had one customer who is asking for a dedicated link between his different sites, right? And apart from that, he also wanted to have privacy of the traffic or the subnet that he is using in his company or in his own network, right? So here, uh, with privacy, I don't mean encapsulation or something. So the term that I mention here is it means that the customer is asking that the subnets or the networks that he is using in his own network, they should not get merged with any other customer. Okay. So what was the solution back those days? There was frame relay, right? But if if you are familiar how the frame relay works is it was a flat L2 and a L1 or L2 path that the ISP used to provide to a customer, right? So, for example, it worked like this. So let's say the customer is asking for a dedicated connection between his hub site and let's say this is two different location of that customer. This is site 1 and this is site 2, right? So what the ISP will do is they will provide a dedicated link between all the sites that the customer wanted. Let's say this is the hub site and two remote sites. So the ISP used to provide dedicated link, right? It was a flat layer one, or you can say just a layer two link between your different locations. That's it. So now it's your job to run um any dynamic protocol or something to exchange the routes, right? So let's say this is my hub location, and let's say we are running EIGRP, right, between my hub location and my remote locations, right? So just they used to provide you just the connectivity between your different sites, and their job is done, right? So now it's your responsibility to configure your devices, to put the routing protocol and all, and exchange the information. Also, let's say apart from the connectivity between your sites, the customer also wanted to have an internet connection. So in that case, the ISP will provide a different connection, right? Let's say you also wanted a internet connection at your hub site, right? So the ISP used to provide you a separate connection for that, and for that they were charging you some extra money, right, for that, because they are providing you a separate dedicated connection for internet. So that is why the cost was a bit high back those days. But now when we are using mpls, so with a single link, or I would say with a single mpls connection, you can have the connectivity between your different sites, and also with the same link you can use internet, right? So it's a bit simple now. So and also cost is low, right, as compared to the frame relay technology and all, because back those days, if you wanted the connectivity and as well as the internet, then you had to pay double, right? Okay, let's see what's next. Okay, one more thing before we move to the next slide. So as we see in the frame relay, let's say if you log into your hub router, or one of the edge router of your hub location, right? And let's say we were running EIGRP, right? So you needed to form the neighborship I mean, there was a direct neighborship between the different locations, right? Let's say this is router number 2, this is router number 3, and this is router number 1. So if you are at R1 and you are doing a show CDP neighbor, let's say, then you will see both these routers, right? In the CDP neighbor, you will see R2 and as well as you will see R3, right? Because as we discussed, the ISP was providing you a flat connection, right? It was a flat layer 2 connection. So your devices used to see each other directly in this CDP neighbor, right? But in MPLS, this is not the case. In MPLS, you are going to have the connective, because let's say this is your edge router at the hub location. So you are not going to make a direct connection between your other location. So before that, there will be the ISP device which is going to make neighborship with you, and there will be another ISP device that is going to make neighborship with your another location. So you will send the route to the ISP device from here, and now it's the job of the ISP to exchange your routes, and then from this ISP it will send the route to your spoke locations. Same is the case with your third location. There will be another ISP connection, and this is how it works, right? So in MPLS you will not be having the direct connectivity between your edge device, but you will be having neighborship with the ISP devices. Okay, so this is another difference between MPLS and the traditional frame relay, I would say. So this is what I have written here, that we already discussed. The very first point is MPLS works on peer-to-peer basis. Two different sites devices will not form peering with each other like frame relay, but with ISP, right? That we already discussed. The second bullet point that I mentioned, this one also we already discussed, that in case of frame relay, there was a separate internet connection that was needed, right? So the cost was a bit high. But now with MPLS, we can fulfill both the requirement with one single link. And in if you talk about the traditional IP routing, if you are familiar with it, so let's say we have this 1.1.1 network at R1, and we have this 4.4.4 network at R4. If we are doing a ping, if I'm doing a ping, let's say 4.4.4.4 from R1 using the source, let's say this is the loopback 0 IP at R1. So loopback 0. So now in a traditional network, how does it work? So I'm at R1, so I need to go to 4.4.4, right? So router 1 will check its routing table, and it will see how to reach 4.4.4. So in that case, it will find out what is the next hop for this particular destination. So here the next hop is, let's say, 12.0.0.2, right? Now it finds out what is the next hop for this particular destination. So now again there will be a second lookup in the routing table to find out how to reach this next hop, right? So then it will find out, okay, so this is the exit interface to reach this particular next hop. So now the traffic, it will forward the traffic or fast ethernet 0 by 0, and now the packet reaches to R2. Same thing, now R2 is going to check, it is going to check its routing table, it is going to find out how to reach 4.4. It will send the packet here, the packet will reach at R3. It is again going to check 4.4.4 in its routing table, and based upon that it will also do the recursive lookup to find out what is the exit interface, and finally the packet will arrive at R4. So in the traditional IP routing, let's say you do not have this 4.4.4 network at R2. So these two IPs 1.1.1.1 and 4.4.4.4, they cannot communicate with each other, right? As soon as the packet reaches at R2, let's say it doesn't have this 4.4.4, the traffic is going to be dropped. Or let's say it has the route, but R3 doesn't have this information, so R3 is going to drop this packet, right? But in MPLS, so I'm just giving you a quick overview, right? We are just we'll see when we go into the lot more details of MPLS. But I'm just giving you a heads up for I mean how the traditional IP routing works. And in MPLS, so let's say this is the provider edge router which is connected to one of the customer. Let's say this is the customer CE. This is the router which is at the customer location, and let's say this is the PE router, the ISP router, right? This is also the P router, the ISP router, which is connected to the another location of the same customer, CE2, right? So in that case, in the MPLS VPN, let's say there is some network 10.1.1.0/24 at this site. So if CE1 wants to send this particular subnet to CE2, so it will advertise this particular network to the PE. Now there will be a IBGP neighborship between these two PAs. Okay, so this particular subnet will not be visible to R2 and R3. So R2 and R3 does not need to have this particular subnet to route the traffic, unlike the traditional IP routing that we discussed, right? Because in traditional IP routing, the destination must be present in the routing table of each hop, right? As soon as we lose the connectivity on any hop, your traffic is going to be dropped. But in MPLS, only the edge devices that will study in deep, only they know these routes, and all the transit devices, they will just switch the traffic based upon labels. They don't have the actual information. Actual information is present only on the edge device. Okay, so this is how the MPLS is going to work. So we will see each and every topic in a great detail, one by one. Okay, so before we go into the actual MPLS details and all the topics, first we will see a quick overview of this foundation topic, which is the VRF Lite, because there is extensive use of VRFs in MPLS, right? So uh, it's my personal opinion that if you are not familiar with the VRF Lite, then I mean, first of all, you should know what VRF Lite is and how it works, and what is the drawback of using VRF Lite and why we don't use it in MPLS. Okay, so we are going to see the VRF Lite in our next lecture with a quick small practical also. Okay, so if you have any suggestion or any feedback, any query, so you can write in the comment section, or you can also write me an email. Maybe you want me to discuss some another topic or any problem. So I would love to discuss that. Thank you.